Good morning, ladies and gentlemen. Hello and welcome, everyone. I think we can start our webinar today. I'm Nanda Suito, your moderator today. You may call me Nanda or Suito. For me, it's the same. Thank you for taking again your time to join our webinar today. We are going to talk about the cost-effective treatment for high-polluted wastewater. After joining today's webinar, you will leave with the knowledge of which method is the most efficient to handle your waste, and also which treatment technology is very cost-effective and suitable to treat your leachate and high-polluted wastewater. We have also a free gift for you at the end of the session, only for you who actively address your questions to the speakers. So stay tuned to learn more about it. And to make sure that I can help as best as I can on this topic, we have a chat box to source your questions. You are very welcome to write it down either in English or in Bahasa, and I will address and translate the questions and address it to the both speakers. The speakers will then answer each question in Q&A session, which will be the end of the session from the main speakers. Selamat siang Bapak dan Ibu, saya ucapkan selamat datang dan selamat bergabung dalam webinar kali ini yang bertema The Cost Effective Treatment for High Polluted Wastewater. Nama saya Nanda Suito, Bapak dan Ibu dapat memanggil saya Nanda atau Suito. Saya akan menjadi moderator dalam webinar kali ini. Bapak dan Ibu juga dapat menuliskan pertanyaan dalam bahasa Inggris atau bahasa. Saya akan mentranslasikan pertanyaan tersebut dan mengajukannya kepada narasumber. Pada akhir acara akan ada hadiah menarik yang akan dibagikan kepada satu penanya. Also, don't worry about making notes immediately, since we will send to each of you the slide presentation and also will upload the recorded video in our WEHRLE social media account. You will receive as well the link of the video after the end of this webinar to your registered email. So as you may know, we will have two speakers today, as you may see on the screen, which are Mr. Kevin Negoro Kasih, the Executive Board of BlackForest Solutions, or we can shortly call BFS, and our main speaker, Mr. Simon Goetz, the Area Manager for Asia and Middle East of WEHRLE, or we can also shortly call WEHRLE. Before we have Mr. Simon Goetz on the screen, I would like to welcome Mr. Kevin Negoro Kasih, who will speak about the importance of the landfill and industrial plant management. It is very interesting since Mr. Kevin on his website has quoted as follows: high quality and safe waste treatment solutions are needed even where high environmental standards are not yet implemented, whether through professional hazardous waste exports or through on-site consultations. BFS is there to support local waste management approaches. Or in bahasa, I can translate, solusi pengolahan limbah yang berkualitas tinggi dan aman sangat diperlukan meskipun standar lingkungan yang tinggi belum diterapkan, baik melalui ekspor limbah berbahaya yang ditangani secara profesional ataupun melalui konsultasi di tempat. BFS hadir untuk mendukung pendekatan pengelolaan limbah secara lokal. Mr. Kevin, it is very interesting knowing the fact that BFS assists the client to manage the landfill and industrial plant. Would you mind sharing with us through your presentations which aspect in the landfill and industrial plant management that need to be concerned by the owner? Shall they focus only to the waste management? Please, Mr. Kevin, the screen is yours.
Okay, terima kasih Nanda. And hello everyone, selamat siang. I speak in Bahasa Inggris because my Bahasa Indonesia is not good enough for a presentation. But first of all, I'm going to share my screen. 1 second. I'll also try to keep it very short, sir, because I know your time is precious and I'm not the main speaker. Actually, the main topic of today is, of course, wastewater and leachate water treatment, and this is the great expertise of WEHRLE or WEHRLE in short. Why am I here today? Because we give a little bit of glance of the other side of wastewater, which is solid waste. And I want to show the connection between our part, like solid waste, industrial hazardous waste, and wastewater, why it's connected, which chances are there, and which challenges as well. So in very short, that you know who's speaking to you, I can very shortly introduce myself, or BFS, our company. Then I'm going to talk about waste management potential in Southeast Asia. Of course, only in 2 minutes, so this won't be excessive, but at least to give a glance. And mandatory infrastructure, which we always see. So first of all, BFS, what do we do? First, we can roughly say that we do two things. First of all is trans-frontier shipment. This means that we are a licensed company which imports hazardous waste and very toxic waste to the European Union for final disposal. So it means that we go to countries where there are no treatment infrastructure for very toxic or very special materials like mercury or arsenic or cyanides or cytotoxic medical waste or oil and gas. And we do the repackaging, the licensing, the logistic and everything until the final disposal facility in Europe. This is one part, but actually our methodology is always that we say on short term, it's fine to export hazardous waste or hazardous materials. On the long term, it's better when countries also like Indonesia or the Philippines or Vietnam or so, no matter where, that they build up their own treatment facility capacities, that we don't need to ship things around, and also to give the value chain to the generation countries. And this is where the second part kicks in, the consultancy part. So BlackForest Solutions is a technical consultancy for hazardous waste, but also non-hazardous waste, like marine litter, like electronic waste, and others. And we have our headquarters in Berlin, Germany, but we also have offices in Rio de Janeiro now, in Brazil. We opened one branch in Mumbai last week, and we have a seat in Dubai in UAE. Okay, I skipped this a little bit because I talked about it already. Whoever is interested in more about our company can jump to our website and feel free to contact us anytime for any hazardous waste or non-hazardous waste inquiry. But now to the topic of Southeast Asia. So what's the waste management potential in Southeast Asia? I shortly saw the list of participants. I cannot see it right now, but I saw that there are many participants from Indonesia, I guess, or from the region. So I guess you know the challenges better than we do. There are a lot of challenges, but also chances in the waste management sector in Southeast Asia. So we divided this topic roughly in 2 points. First one is GHG emission reduction potential, so greenhouse gases, and second, value creation. Value creation is a bit more obvious maybe. That's why I start with the GHG. So what do we mean with that? Here in this table, we see the categories, the industrial categories, and the related GHG emissions per year in megatons from 2016. Of course, it's not really accurate or actual, but it gives a slight indication of what we are talking about. And in this whole greenhouse gas emission discussion, often these first parts, like industrial wastewater, unmanaged MSW disposal, and domestic wastewater, of course also open burning, are often not very much discussed. So we talk about carbon dioxide emissions from cars, from planes, from whatever. There's a big discussion from industries as well for carbon credit purchase or production and then sales on the international market. But these points here, the waste management sector and wastewater sector, which have a great GHG emission reduction potential, are actually not so much in the media, in my opinion. And this is a very important point. First of all, of course, for the sake of the environmental and public health of a country, is it Germany or Indonesia or somewhere else? But second, also as potential for business, right? So many of you probably know that a reduction of GHG, is it CH4 methane or is it CO2 or whatsoever, can result in a business case as well when we talk about carbon credits or services to industries. So what I want to say with this table is that these points here have a massive reduction potential, and this is mostly untapped. I know this quite well for here because right now, sorry for the noise and so on, because I'm in a industrial wastewater treatment facility in Saudi Arabia right now, where we consult the Saudi Arabian state on how to reduce the GHG emissions. So it's exactly that case. So we see that, especially in oil and gas, but also in other sectors, which are also relevant for Southeast Asia, the GHG emission reduction could be one future business case or one financing source also for critical infrastructure. And the second reason why waste management is a little bit connected to wastewater, or actually always, the value creation. What do we mean with that? First of all, if we are able to separate the waste types, for example, dry and wet, or let's say organic fractions and non-organic or recyclable fractions, two things happen. First one is that we decrease the cross-contamination of valuable waste, for example, of valuable plastic types, and also we increase the recycling rates and therefore the turnover of facilities. And second, we can try to divert at least the organic waste from landfills, which again create two things. First one, GHG emissions in form of CH4 or then later CO2. And second, we prevent or we reduce a little bit the leachate water contamination. And here is where I slowly build the bridge to the main topic here, which is Vela, because we as waste management company always come to the point where we get in touch with wastewater, and as usual, we then call Vela. I guess they did me the favor that I'm honored to speak today very shortly. So what I want to say is that always the solid waste or also the industrial waste sector and the wastewater sector are interconnected. In some cases, is it leachate from landfills? Is it direct industrial wastewater discharge or so? And I guess most of you joined this webinar and this very short talk because you're interested in the waste management sector or you are already wastewater specialists, so you know, and I don't tell you something new, that leachate and wastewater treatment is very important. Like, of course, plastic waste on a landfill is bad, but the emissions coming from biogenic fractions or industrial hazardous fractions going to the soil and to the air, of course, to the groundwater, are very, very bad and really have to be considered. And in many countries where we work, like also in Saudi or in the whole Middle East, but also in Latin America, we see that the awareness raises because at a certain point, the public will be also very, very interested in the groundwater quality, right? So leachate for us is the point where we as BFS say, here we stop. We don't know anything about leachate because it's a very complex topic. Like from the wastewater perspective, for us, a CP unit, like where I'm here right now in the facility, is okay, understandable, but at leachate water from landfills, for me, the understanding stops. And here, I'm also very happy to hand over to Vela again. I think I did not cross the 8 minutes, huh? So good in time, or I overdosed?
No, it's fine.
Okay, good. So my last statement is pollutants from landfill leachate, because we have to do with it every day. We do landfill audits very regularly, and we are very, very well aware of the top of the landfill, so to say, about the solid part, but the leachate part is the actual hidden and very dangerous part. And therefore, I'm very interested. By the way, here you see a leachate treatment system from Indonesia. I think this was in Banjarmasin or so. Where we also did the landfill audit. So I'm very happy to hand over to Vela now and learn more about how will you or which solutions do you suggest to treat industrial or MSW wastewater from leachate or direct disposal. And any question for waste, yeah, please feel free to get back to me or in the Q&A. Thank you very much.
Thank you, Mr. Kevin. Thank you for your time. As you have strongly mentioned and suggested before, not only the waste itself needs to be properly handled, but also the leachate which is coming out from the landfill and also the high polluted wastewater, which is the residual products of the industrial processes. It is quite amazing figures that the leachate has potentially GHG emission 49.2%, taking almost most possible GHG emission resources. So yeah, this is something that needs to be handled properly. And I believe the person who is very suitable to speak into detail about this topic is Mr. Simon Goetz, the area manager for Asia and Middle East of Vela. I quoted testimony from Mr. Simon during our talk before, shortly before our webinar. The owners of the landfill or industrial needs to understand that a leachate or industrial wastewater treatment facility shall consume only the smallest footprint or area with the most economical investment cost. Thus, the owner have more land for its industrial production or managing waste from which they can make money. It is very interesting, or I can translate in bahasa, pemilik tempat pembuangan akhir atau industri perlu memahami bahwa lindi atau fasilitas pengolahan air limbah industri hanya akan mengonsumsi atau harus mengonsumsi lahan atau area sekecil mungkin dengan biaya investasi paling ekonomis. Dengan demikian, pemilik fasilitas memiliki lebih banyak lahan untuk produksi atau pengolahan sampah, di mana mereka dapat menghasilkan uang dari proses tersebut. Mr. Simon Coates, since you have 12 years experience, would you share us which technology is most suitable one? Because it is very challenging to find a technology that can treat high polluted wastewater with economical investment, but also occupy only a small footprint. And most important, granting maybe a long operational time, like more than 25 years, for example, which is only possible with excellent operational figures. Please, the screen is yours.
Yeah, thank you very much, Nanda. And also thank you very much, Kevin from BlackForest Solution before for that really interesting presentation. Let me share my presentation with you. Nanda, is it seen?
Yes.
Okay, perfectly. Yeah, so thanks again. To Kevin, to Nanda. Today it's my honor now to talk about the cost-effective treatment for high-polluted wastewater, as Mr. Nanda already announced it to myself. I'm working now since 12 years at WEHRLE here in Germany, and nowadays I'm responsible for the Asian market as well as the Middle East market as the area manager. And now it's my pleasure to brief you and to give you more information about how is it possible to have a cost-effective treatment, and especially a treatment plant which is running not only 2 years, but which is running like a life cycle of 25 years or longer. Okay, first of all, I would like to share with you the agenda about what we would like, or what I would like to inform you about. First is a small introduction where you can see like the topics we will discuss today. I would like to highlight on 2 products from WEHRLE. One is the Mbr Bio Membrane. You can see the small R there. It means it's patented. It was patented by WEHRLE many years ago. It's actually a system from an Mbr unit, but not an Mbr, which probably most of you will be aware of, with the submerged type of membrane. The biomembrane system uses the external membranes. Why we are using this will be explained later on more in detail. The second product what I would like to highlight is the direct reverse osmosis system, which WEHRLE also uses. And when Mbr will be applicable and when the reverse osmosis will be more applicable, I will also highlight later on. The complete presentation will be for the two main fields from WEHRLE, which are actually the landfill leachate treatment, one of the harshest liquids you can find in the world. And the second one I will focus is the industrial wastewater treatment. Also, industrial wastewater usually is really highly polluted, high COD, high organics. Often you will have to handle a lot of salts, for example. So what we are not talking today about is municipal wastewater treatment, since this is not the field of WEHRLE. WEHRLE is really specified and specialized in a niche, which is really the high strength and high polluted wastewater, either from landfill leachate or from industrial. And as the last part of the presentation, I will show you some typical case studies from our plants. Okay, let's talk about WEHRLE in general. As you can see here, this is the WEHRLE premises. It's located directly in the city. It's not located outside of the city. The reason therefore is since WEHRLE was established in 1860, so it's a quite old company, and the company was there, and after the company was established, the city was growing outside. That is the reason why WEHRLE is located now in the middle of the city. WEHRLE is active worldwide. We will see later on a map where we can see the premises, the daughter companies, the partner companies. I think that slide is like 1 year old, because here it's mentioned 220 employees. Nowadays, we can proudly present 260 employees, especially in the COVID phase. We faced anyway a high work pressure and a lot of projects, so that we had to hire more personnel. We are 100% family owned. Even if we are a stock company, we are not listed in the stock market. All the shares are in the hands of the family members of the company, and the equity ratio is more than 50%. And we are doing a turnover of around about $70 million per year. WEHRLE is divided into 3 sections. We have the energy technology section, which is dealing with boilers, and for waste incineration, for example. So that are specialized really in the thermal processes. Also, they're doing burning of excess sludge with phosphorus recovery, which is even more important since phosphorus is running lower and lower in the world. The second part of WEHRLE, or the second division, is the manufacturing, where we are doing our own boilers, where we are doing our own steel pipeworks, also for the plants which we are talking now about, which are located in the environmental section and environmental technology, dealing and handling, as mentioned in the beginning, with high strength wastewaters. So when we have a look a bit closer in the 2 topics, what is WEHRLE dealing with, which is the landfill leachate and also the industrial wastewater, we can see that around up to date is 2/3, let's say 68% of the business and the projects are located in the waste sector, so actually leachate treatment, and 1/3 is located in the industrial wastewater sector. When we talk about industrial wastewater, WEHRLE mainly is focused on food and beverage wastewater, on pharmaceutical wastewater, on chemical and on petrochemical wastewater. That are the biggest industries where we're active in, especially the pharmaceutical one is getting more and more important. The multi-resistant germs, they cannot longer go into rivers, pollute rivers where maybe people consume later on from water from that river, and then these multi-resistant germs come into the human body, which causes problems. Then the person gets resistant against antibiotics, and so on and so on. There are a lot of negative factors when pharmaceutical wastewater gets not correctly treated and when that water comes into the environment. Nowadays, WEHRLE has more than 459 references in more than 40 countries. So that is a clear sign that we are extremely active worldwide. And from that 459 references, Vela has around 301 in leachate treatment and 158 in the industrial wastewater sector. Especially for leachate treatment, experience is extremely of highest importance, since that kind of wastewater is extremely difficult to treat. Nowadays, Vela, through all their experience, through many successful projects, could get it on the list of the top waste management solution providers in Europe in 2021. If you see here in this list, in this ranking, there are a lot of global players. You will see here Suez, you will find Remondis, you will see Veolia Environment, and also Werlewerk, with a relatively small company compared to a company like Veolia or Suez, is ranked now in that listing, where we are, of course, quite proud on. So let's talk about now the two products which we are facing that kind of difficult wastewaters. So here, what we are usually doing, since we are not only a product supplier, since we are a technology company, and since the engineering and the know-how and the technology is our extreme strength, what we are doing since more than 30 years in this field, we are looking what is the load of the effluent. So is it a really high polluted wastewater, or is it only medium polluted wastewater? And of course, we need to see what are the discharge standards, what is required in the effluent. Does the client discharge the water into another sewage system? Does the client discharge the water into the sea or into the river, for example? If he discharge into the river, high standards are required. So therefore, we are looking what is the load of the effluent, what is the effluent quality, and then we are setting our process step by step. If it's a really high loaded effluent, and if a really high discharge standard is required, for example, we can set different technologies. We have the anaerobic technology, we have the aerobic technology like a biostream or membrane bioreactor as a biomembrane, or we have the chemical physical systems like nanofiltration and reverse osmosis, activated carbon. So you see, we are not selling or trying to sell a specific product. We are really a technology company, and we are looking what are the demands for the client. And today we would like to specify on two technologies, which is the biomembrane and which is the reverse osmosis. Here we see a slide where we have different technologies which we are usually facing also from our competitors. Here we have our biomembrane. We have compared with a submerged Mbr, with a Mbbr, with a conventional activated sludge. No question, all of that technology have the right to be in the market and have a lot of advantages. What we are seeing is that those technology have big advantages also compared, for example, to our biomembrane in low strength wastewaters. Sewage treatment, low polluted wastewater, let's say up to 2000 milligrams COD per liter. But if we talk about a really high COD range, up to 70,000 milligram per liter, if the plant or the industry needs a plant with a high TSS flexibility, especially when the plant needs a high ammonia peak flexibility, which we are facing extremely often in landfill leachate. We are facing ammonia values up to 5,000 milligram per liter. We are facing high COD peaks in the industry, for example, when the production, let's say Mondelez or Cadbury, a chocolate manufacturer, is producing or changing their shift and bringing up a new product. The wastewater changes dramatically, the COD can rise up. Suddenly, that means there must be a high COD flexibility. Of course, we are building our plants in Russia, where they have to face minus 20 degrees. We are building our plants in Indonesia, where they face sometimes plus 40 degrees. That means there must be a climate flexibility and a climate stability. The plant should be operator friendliness, because not in all countries of the world you can find like skilled operators. That means it must be really operation friendliness. And of course, a big issue is the membrane cleaning frequency, since membrane cleaning means chemical costs, means operational costs. So if we compare all this, we clearly can say from our experience that the biomembran Mbr has the biggest benefits in terms of high strength wastewater, comparing all these criteria here. Okay, now talk about first about the biomembran a bit more in detail. What is the biomembran from Vela? Usually, as mentioned, you know probably the Mbr, but with submerged membranes. So what is Vela doing? Vela is working with external membranes. Why we are working with external membranes? External membranes has the big benefit that they are not located in the sludge, that they are dried, that they are installed outside in a dry space. If they stuck all the time as a submerged membrane in the sludge, all the time the membranes needs to burden all the chlorides, all the high COD, all the fouling BOD material. That means the membranes gets a really high stress. Especially in leachate, we face a lot of TDS, a lot of chloride, a lot of heavy metals. Those metallic substances, they stuck on the membrane. They are leading to scaling, which is sometimes irreversible, and the operator needs to replace all the membranes, which is a high cost. Therefore, we have external membranes with kind of booster pumps here, where we are pumping the sludge through the membranes with a speed of around 3 to 4 meters per second, which leads to that all the COD and BOD particle cannot sit on the membrane, that the scaling material cannot sit in the membrane, that we have more a clean membrane. This is one big advantage. Another big advantage is through this high velocity, we have a high flux rate. We have usually an average 6 to 8 times higher flux rate than submerged systems, which means the operator and the client thus need to install 6 to 8 times less membrane area. This has an effect on the CAPEX, since the membrane area is 6 to 8 times lower, but really important is also for the cleaning. That means we need much less cleaning agency for CIP cleaning. And also when the client needs to replace the membranes after some years, he needs to replace 6 to 8 times less membrane square meter compared to a submerged system. Also, we have a CIP cleaning. It's called a cleaning in place. That means while we are cleaning one single UF loop here in this example, we have 4 UF loops. All the other 3 loops are continuing running and treating wastewater. So we do not have to lift anything out of the tank, for example. It's a complete cleaning in place system. The other typical part of our biomembran system is the aeration system. We do not work, for example, with blade diffusers. Blade diffusers, we made a lot of experience, especially in leachate treatment, that after 1 or 2 years, the surfaces of the blade and the membrane diffusers are completely clogged and scale, and they are cracking because of the high TDS and chloride values. So therefore, we are using completely maintenance-free jet ejectors. They are also energy saving. They can handle a water level up to 15 meters, which means we can build the membrane bioreactor extremely compact. And also they can handle MLSS concentrations up to 20 grams per liter. Also, the external membranes can run up to 20 grams per liter bacteria concentrations. A submerged membrane usually is limited up to 10 grams per liter. That means we can bring 2 times more bacteria mass into our system here. That means we have a much more compact reactor because we can bring 2 times more bacteria in. We have a much more compact reactor since we can run it up to 15-meter water level. That means we have a really compact plant with an extremely efficient oxygen system, which saves energy. And we have an aeration system installed, which is completely maintenance-free. That is quite important. Those jet ejectors get installed and they are lasting up to 25 years or longer in the tank. Think about if you have a big plant with, let's say, 2000 cubic meter of aeration tank, and you need to replace your aeration system like a membrane diffuser because it's clogged or cracked, and you have to discharge 2000 cubic meter of activated sludge. That is a really big problem that costs a lot of money, and that will stop your production. Here we have the schematic drawing, a bit more here like in a 2D scenario. We see here the jet ejector. On the one side of the ejector, we are pumping the sludge in a circular way out of the tank and pump it into the ejector. From the top, we pump air inside. So the air and the bacteria gets mixed in the jet ejector and gets spread out in the tank. Before, usually we have a balanced tank. In a leachate case, it can be a leachate lagoon. And then here we have our external installed ultrafiltration unit. And the big benefit of a biomembrane system is that the outlet, the discharge, is completely TSS free. There are absolutely no solids anymore, 0 milligram per liter solid, since it's a membrane driven process. And therefore a later upgrade, for example, with a reverse osmosis or nanofiltration is really easy to adapt. Often industrial clients in the first step, they have only the budget, or they want to invest only in the actual wastewater treatment plant. And in a second step, 1 or 2 years later, they would like to recycle and reuse the water, which is also a topic of today's presentation. So then they can adapt easily a reverse osmosis system. And after the reverse osmosis system, the water is a kind of, has a kind of, how can I say, cleaning potential that it can be reused back in the cycle of an industrial process, which of course saves money, which saves OPEX cost, and which gives, of course, the company a really good reputation in terms of climate friendly. Okay, that was some sentences to the membrane bioreactor system, to the biomembrane system. Now I would highlight more on the chemical physical way, which is the reverse osmosis, the second product we would like to discuss today. So what WEHRLE is actually also doing is the direct reverse osmosis plant located in a 40-foot container, a really compact design. This is actually for clients which are facing a little bit lower budget, like for a biomembrane unit. And of course, this has also disadvantages. A direct reverse osmosis plant has advantages and disadvantages. In the next slide, we will talk about that, or in the next slides. Here we see a 3D model of such a 40-foot containerized unit. Everything is located inside the container. We have here 2 sand filters as a pre-filtration for suspended solids. We have here a CIP tank, because also those membranes are cleaned by a CIP cleaning. We are not working with disk modules, for example. We are working with spiral round elements. We did really good experience with those kind of membranes. And here we see it from the side view. Also for warmer regions like Southeast Asia, we are providing those containers, of course, with the air conditioning unit. For containers which are going to Russia, they will have installed a heater. So everything is installed there. It will ship on site. The client only needs to build up a small basement. It doesn't need to be a complete basement. Usually 3 stripes or 4 stripes of basement are sufficient. The container will be placed there. It's completely pre-tested in Germany already here in our headquarters. It will be sent on site, placed on the basement, and really easily plug and play, and the treatment process can begin. So here we see WEHRLE has 3 sizes of containerized. We have the S, the M, and the XL containerized type. So for example, if a client is facing now 140 cubic meter per day inlet of leachate, and let's say he has around 10,000 of TDS, actually it would be an M container. But let's say he has also 18,000 of COD, then this one here is the driving criteria, then 140 cubic meter, 18,000 here. We would offer him a XL container variant. So this is just an example how we are usually then acting with those three types of those containers. And of course, when we look a bit in the recovery rate, the higher the TDS value gets, the lesser the recovery. So that is because due to the osmotic pressure. And what we also see here is that we have 1-step, 2-step, and 3-step RO containers. This depends strongly on the effluent discharge requirements. If, for example, the client needs to have really low TDS values in the discharge, really low ammonia, it can be, depending on the inlet criteria, that we are offering a 2-step or a 3-step RO. That means that the permeate, the clean water from the first step, goes to a second RO and gets pumped through pressure vessels. And if that permeate production still is not clean enough, it still gets to a third reverse osmosis step. So, but then what is the disadvantage of a reverse osmosis? Because the client must spend lower budget than to a biomembran, and of course, permeate, a clean water of reverse osmosis, is really, really clean and pure, and is also salt-free. The big disadvantage of a reverse osmosis is the concentrate handling, because a reverse osmosis process does not eliminate the contaminants like a biomembran system or a biological system that eliminates the pollution. A reverse osmosis unit is separating the pollution. That means it separates the pollutions into a clean permeate flow and into a really dirty flow. That means on a reverse osmosis unit, you will always have a concentrate stream. For example, you bring in 100 liter really dirty water in a reverse osmosis unit, you maybe get 80 liter of really clean water and 20 liter remaining of really dirty water. And this is a problem, because this water needs either to be externally disposed, which creates high disposal costs, which has then a big effect on your operational costs when you're running the plant. Or what often clients do, especially in landfill leachate applications, they are returning back all those high polluted concentrates back to the landfill, which means 98% of the pollutants get returned to the landfill site. So you can imagine it's only a question of time how and when those pollutants come into the leachate. That means the TDS value, the COD value of a landfill leachate increases drastically over the time when this high polluted concentrate gets returned. So if we look a bit on the removal rates of a biomembran Mbr unit, and later on we compare it with the reverse osmosis, we can see that biomembran unit is really effective in nitrogen removal, is relatively effective in COD removal. If the COD contains a high BOD, we can put also here green belts on. But why it's not completely green here means the really hard COD, the non-biological treatable COD, remains in the system and will not be treatable. Therefore, we cannot do this here completely up to the top. It completely removes and caps back all solids. Therefore, the effluent is completely TSS-free. A membrane bioreactor unit, the biomembran, does not treat or keep back salts. So if you have salts inside your leachate, they will also come out here. This is an important thing. And we have a relatively low removal of TROC. If we compare this now with a direct reverse osmosis treatment plant, we see, especially here, it's the schematic is done for a 3-stage reverse osmosis unit. So the highest cleaning rate you can get with a reverse osmosis unit. We have a high COD removal. We have not so good nitrogen removal, since nitrogen is an ion which is really small and goes easily through the membrane. We can reject almost all solids, or we are rejecting all solids and all salts. So this is something which is important to know. A reverse osmosis membrane keeps back the salts compared to a membrane bioreactor. So now the question is, okay, as mentioned before, why then to go for biomembran when here those things are lower than here? And also it's cheaper, the direct reverse osmosis in Carpex. Here the clear answer is the concentrate issue. This process here will bring you up a concentrate, in this case here, for example, between 30 and 40%. So let's say 100 cubic meter per day go in, you will still have 30 to 40 cubic meter high polluted concentrate. And you have to do something with it. You have to dispose it again, which leads to costs. And if you return it back on the landfill side, you will have a strong increase in your salt, in your TDS, in your COD concentration, which will come from time to time to your system. And one day the system will collapse down. Therefore, a direct reverse osmosis plant is an excellent solution for a short-term solution. For example, when the client needs now in the next 4 months a solution, but he runs it only maybe for 2 years. Then for those 2 years, maybe he can recycle it back to the landfill site. And after those 2 years, he installing a proper system like a biomembran unit. If there is the demand to really treat COD, BOD, ammonia, and also salts, the combination what we have installed plenty of times in the world is the combination of a biomembran process plus a reverse osmosis, because that unit here will do the job for the COD and for the ammonia especially, and for the TSS, and this unit here will do the job for the salts. Of course, now the question probably comes up, but here is also concentrate. Yes, but this concentrate is much cleaner than the concentrate from a direct reverse osmosis, because here we have already a high cleaning efficiency and a high cleaning stage here. So that means the water which comes to the reverse osmosis unit is much cleaner already, and those here is usually doesn't contain, for example, a lot of organics anymore. So therefore, the combination of those processes can remove almost all the critical substances and pollutions. What we are seeing here is a typical chart from an industrial plant. This comes from Unilever, from I think a food and beverage project. This is quite a typical COD curve here from an industrial process. They're changing their products, what they are producing. Sometimes they get shock loads in the production, etc. That, of course, has effects on the wastewater. That means when we have in the contract, the plant needs to handle, for example, 17,000 of COD, the plant will never face only 70,000 COD. It will face a lot of fluctuating inlet concentration. And therefore, it's extremely important that the system is robust and reliable. Because if the system cannot handle those fluctuations, the complete wastewater treatment will start to struggle. When the wastewater treatment start to struggle, maybe they discharge higher COD values than are allowed to discharge into the river, and then they need to stop the production because the wastewater cannot handle it, and that will cost a hell of money in the end. Therefore, we are building the plants really reliable and really sustainable. And this is here the outlet curve from this Unilever plant. You can see even when the inlet concentrations are quite fluctuating, we have a really stable COD in the outlet. Okay, finally, I think I'm talking now already around half an hour. We have already gone through. We will look now to a few case studies for those products. What you can see here is typically not what you expect when you think in a big wastewater treatment plant, but this is one of the most important benefits from the WEHRLE plants, really compact, really space saving. This here, for example, is the Mbr plant in Romania, and you can see it's directly located in a neighborhood area. Why? This is possible because the really small footprint and the plants are also odor-free. So there is no smell burden for the people which are living around. What we are seeing here is an anaerobic reactor, EGSB reactor in Unilever client in Gloucester. Here we see external membranes installed from the plant in New Zealand, for example. This is in England. So all characteristics that you can see, compact reactors and high. Here we see a project where we needed to upgrade an industrial plant. This was the plant from a competitor. After 3 years, this plant was collapsing down and we got called because the client was retendering. WEHRLE got the contract, and what we was doing actually is that we could remove all those existing equipment, and WEHRLE installed a new plant, and the footprint of the completely new plant, which was handling exactly the same amount of wastewater, which was needed all those space here. We were building this plant here, and it consumed only this amount of space. That means the client for the future has all this space available for his production. And this is the thing which is profitable for him and which gives him the money, not the huge wastewater treatment plant, but a huge production and a really compact and effective wastewater treatment. Again, if we summarize, what are the important things for the WEHRLE plants? Dynamic operation, fluctuating inlet concentrations, reliable outlet concentrations. Modular design, really important. We saw the UF membrane loops. Why modularity is so important? Industries are growing. They are growing. So maybe they are starting with one product. After 2 years, they are implementing a new product. Maybe Kraft Foods, for example, they started with ketchup. After a while, they did mayonnaise, maybe other products. That means more wastewater. That means the wastewater treatment plant needs to be able to grow with the industry, but it needs to grow in a way that not the complete fabrication needs to have a shutdown because the wastewater treatment plant needs a really sophisticated upgrade. No, it must be that the industry can continue running and the wastewater treatment plant modularly will increase, but without inhibiting the production. And as mentioned, easy to operate. Also, WEHRLE usually equips their plants with remote control. That was also quite important now in the COVID phase, where we couldn't travel to Indonesia, for example. In Indonesia, we are commissioning plants right now remotely. That means the operator, he has a VR class and he's connected with our operators here in Germany, and they are like using him as a dummy and telling him, okay, now go there, go there, go that. And that is all possible about remote control. And after that plant is commissioned, also the plant can be completely operated via remote control. When we look a bit more in the region where most guests here are today from Indonesia and Malaysia, we can see here what we are doing there is, sorry. So if we are look here, we are a bit of time ago, we got the project Leachate treatment at Negeri Sembilan. I cannot say the name of the customer since it's not allowed to disclose the name. I only can say it's one of the biggest solid waste management company in Malaysia. There we got awarded 1 year ago the contract to build the leachate treatment plant for extremely dirty leachate for 600 cubic meter per day. There is the process, a really sophisticated process, because the inlet concentrations are really high. The outlet concentrations are really strict. So we have a biological step, we have a chemical physical step, we also have an evaporator there. So a really sophisticated process to be able to reach the discharge standards. We have also industrial wastewater treatment contract won in Kuala Lumpur. Monin is a syrup producer from France. The headquarters is in France. If you, for example, go to Starbucks, you usually see in the background, you have those syrups from Monin. They are producing syrup, they produce wastewater there, and we got called to upgrade their existing plant. Also, the contract is in a modular way. We are starting with a certain amount of wastewater. We are building the plant, but in the contract is assured that after some time, when the wastewater is increasing, that our plant will also increase. For Indonesia, we already won 4 projects for leachate treatment plant. That was in the ERIC program, Emission Reduction in Cities program, which was financed by the KfW Bank. located at 4 cities in Jambi, Jombang, Malang, and Sidoarjo. There we are building biomembrane plants to treat their landfill leachate. Finally, a few case studies. This is a Unilever case study in St. Petersburg in Russia. We are facing 18,600 milligram in the inlet, and we can reach here 92% of degradation. This is one of the biggest, or the biggest biomembrane plant in Thailand. It's for a petrochemical company, IRPC. And you see, we are really flexible also in the flow rate. Sometimes we have flow rates from 30 cubic meter per day up to more than 6,000 cubic meter per day. Here we are treating 4,600 cubic meter a day. This is FNN. I think probably all of you know this from Malaysia, soft drink producer. That was interesting project since FNN had already a conventional system, but they needed to upgrade since they increased their production. And then we are converted the conventional system into a biomembrane. That means we were increasing the bacteria concentration in the existing tanks, and we installed an external ultrafiltration unit since the sedimentation tanks cannot handle the increased MLSS ratio. Also a project, Gasa in Kuala Lumpur, a jam producer from Italy, where WEHRLE could install their biomembrane process. And finally, what we saw already, that are the 4 projects which we won in Indonesia. The interesting thing here is in the tender, it was stated that there must be an anaerobic pond followed by our biomembrane, followed by a wetland. That was in the tender. The WEHRLE biomembrane you can see here, and you see here the anaerobic pond, and you see here the wetland. And the interesting fact is that our plant here consumes the very less space, but it handles 75% of the pollution completely. That is quite an interesting fact and shows how compact WEHRLE builds those plants. So I hope that was interesting information for you, and I could highlight you a little bit about the 2 products which WEHRLE is having inside of a big portfolio of different technologies and products. Today it was the target to highlight you 2, and especially for our fields and landfill leachate and industrial wastewater. Thank you very much.
Thank you very much, Mr. Simon, for giving us this presentation. I will probably, you can see my screen, right?
Yes.
Okay, so thank you again for showing the compact activities of WEHRLE, and also strongly highlight that the plant operator or the owner of the leachate and industrial wastewater treatment plant needs to occupy only limited footprint. It really makes sense, actually. Then the question is always why we have to build as huge as possible wastewater treatment, which is actually doesn't have a really high benefit in terms of the income for the operator. And some of the operators probably think before that there is no such reliable technology, but now we have the knowledge already that depending on the load of the wastewater, there are reliable technologies such as Mbr Bio Membrane and direct reverse osmosis. I believe I have seen many questions coming to me personally through direct chat, and also I saw several in the chat box. I will now then read the questions one by one and address to the respective speaker. The first question is coming from Mr. Lee to Mr. Simon. Is there any special setup for your containerized direct reverse osmosis? Is it always in a container?
Okay, no. The answer is clearly no. We are also, especially or often for Southeast Asia, they have like a machine hall, and they do not need a container. Containerized unit is really if there is just a rough landfill site and they do not have a machinery hall, then the containerized is very suitable. If there is a machinery hall, we also build the direct reverse osmosis plants just on a rack basis, and we are shipping the rack without a container.
Okay, so there are two types, either in container basis or in the rack basis, but the setup of the container itself is the same, like as what you have already presented to us, right?
It's standardized, yes.
Okay. Okay, the second question is coming from Mrs. Hajra. Would you please explore more about the energy consumption of Mbr Bio Membrane technology, Mr. Simon?
Okay, the energy consumption of a biomembrane is slightly higher than, for example, from a submerged plant. Why? Because we have those booster pumps. However, if you are considering the total OPEX or operational cost, the OPEX cost, the biomembrane is the cheaper solution, because the OPEX does not only cover electricity, it also covers the chemical costs. And the chemical costs in the biomembrane process is much lower than in a submerged process. So to answer, the energy consumption in the biomembrane technology is higher than compared to other technology, but the overall OPEX costs are lower.
Okay, so Mrs. Hajra, that was the answer. Maybe if you want to follow up the answer, please kindly write it again in the chat box. Then to the next question, still related to the Mbr biomembrane technology. So the question is from Mr. or Mrs. Hang. Is the TKN oxidized in totally in to nitrate or nitrate in the aerated tank as well?
Exactly. This is one of the main job of the Mbr or of the aeration tank. TKN contains of ammonia and no, I don't know the English word. Contains of ammonia and unorganic nitrogen. And usually in the leachate, mostly of the TKN, let's say 95% is ammonia. And this ammonia in the nitrification tank gets oxidized first to nitrite, NO2. In the second step, still in the nitrification tank, from nitrite to nitrate, and then it gets pumped back to the denitrification tank, where it's then get denitrified from nitrate into elementary nitrogen gas, and that leaves the reactor. So that is one main purpose and one strength why the Mbr unit, for example, can handle up to 7,000 milligram ammonia in the leachate.
Okay. I believe we have the next question, but it is addressed to Mr. Kevin. It's coming to Miss Prita. What is more important here, to start with a solid waste management or a wastewater management in emerging states?
Yeah, hi Nanda. Thank you
Hi.
for the question. I think, like me as a waste guy, would of course say waste management, but to be realistic, I think it's always best to start both in parallel. Of course, depends on the explicit challenge. Like when we talk about building, constructing a landfill for MSW, especially mixed MSW, then both the wastewater treatment, leachate treatment, and the landfill treatment or planning has to start in parallel. For industrial operations and so on, this can be sequential.
Okay. Yes, so this is Mrs. Hajra following up the question previously to Mr. Simon. Is there any potential to combine the leachate power plant with the biomembrane for the energy consumption?
I'm not sure if I get the question correct. Does it mean that, for example, when there is gas from the landfill site collected and maybe with a CHP burned into energy or into power, if that power can be used for the biomembrane? If this is the question, then the answer is yes. That's possible for sure.
All right. And the next question is from Mr. or Mrs. I don't know, Liao. For high COD influence, Mr. Simon, isn't it easy to be affected by biofouling in the case of direct reverse osmosis operation?
Yeah, thank you. Good question, for sure. Direct leachate has high BOD and high biofouling, absolutely. What we are doing is we are using spiral rounded elements which have a slightly bigger spacer. That bigger spacer inhibits that there is too much fouling. Still, there will come fouling. Therefore, we have CIP cleaning, which we are usually do, let's say, every 7th to 10th day in a CIP cleaning process. But the most important fact is that our direct reverse osmosis system is not like a normal pine tree RO system. We have the so-called feed and bleed system. That means that we are not only working with a high pressure pump, but only working with special booster pumps. That means the high pressure pump brings the liquid up to a high pressure level up to 80 bar. Our direct reverse osmosis plants working up to 80 bar. And then we have an extra pump next to the pressure vessel where the membranes are located. That pump has just the job to recirculate the concentrate through the membranes, and therefore is a high velocity through the membranes, and that makes it more difficult for the BOD to stuck on the membrane. So we are fighting against the biofouling through regular CIP cleaning, usually alkaline and acid, and also through this feed and bleed design where we have a special pump to bring up a high velocity to make it more difficult to stuck on the membrane.
All right, so the CIP and also the feed and bleed system will try to combat in a very good way for the biofouling. Yes.
Exactly.
Okay. Going to the next question, still to Mr. Simon, is coming from Miss Anna. Association of Southeast Asian Nations, or ASEAN, regulates the local content measures, which vary between 30% to 50% for each country. Since this technology is a German technology, how do you tackle this challenge? How much percent is your local content compared to your complete components?
Okay. In this case, we have completely freedom of business models. What is important is that our design and engineering is coming from Germany. However, also to be more competitive, we are doing this also not only to follow by this regulation, but also just to be more competitive, that we are using a lot of local material. For example, for the ERIC projects, pipework material, for example, electrical wiring, electrical switch cabinets, were from sub-suppliers from Indonesia. So we can have a really high local material content without any problem. The important thing is the engineering shall be coming from Germany, but of course we do not ship electrical switch cabinets over. Okay, it depends on the contract. Some contract and some clients, they prefer to have everything, also the equipment from Germany. That's possible, is a question of the budget. But usually to be more competitive, for sure, we are bringing in a lot of local contents. Also, we are having our daughter company, WEHRLE Asia, in Kuala Lumpur, where we have also our small own workshop, and that also covers that that demand from the ASEAN nations.
All right. Still following up with this project references, another question from Mr. Yanwa. You have highlighted ongoing projects in Indonesia and Malaysia. Do you have also project references in another Southeast Asian countries? And do you work at the moment with a local partner?
Yes, we have. We have references in Singapore. We have also references in Vietnam. We have references in China and Korea. Okay, that is East Asia, not Southeast Asia. But for Southeast Asia, clearly Thailand, Malaysia, Vietnam, and Indonesia. Actually not in Laos and Cambodia and Myanmar, for example. And yes, we do have partners. In Thailand, for example, we have a partner company. And usually we cover Malaysia with our daughter company. And also Indonesia we cover with our daughter company. But we are really open and flexible in business models. Sometimes we work together with partners Sometimes we do the complete projects with our daughter company in Malaysia.
All right. So it's I can say it's quite flexible in terms of business. The next question is coming from Mr. Pablo. Thank you again for the presentation. Could you explain the difference between the required pre-treatment in both treatments between the direct reverse osmosis and Mbr Bio Membrane?
Yes, good question. Usually the direct RO needs a higher treatment because the spiral round elements, they cannot handle, for example, high concentrations in suspended solids in TSS, also not in oil and grease, because that sits on the membrane and reduces drastically the flux rate, compared to a biomembrane system, which is extremely robust. A biomembrane system, for example, can handle 1,000, 2,000 milligram per liter TSS compared to suspended solids, compared to a direct reverse osmosis, which is limited, let's say, to 30 or 40 milligram per liter TSS. That means the pre-treatment for a direct reverse osmosis system must be more carefully chosen and maybe more sophisticated than for the really robust biomembrane system.
All right. So I think it is also connected to the next question from Mr. Nguyen. So how easy is it to use the local chemical for WEHRLE treatment plants? Because you mentioned that there are several chemicals that probably going to be used.
Vela actually has their own developed over many years of experience, developed membrane cleaners, which are working extremely efficient. However, especially in Thailand, for example, it's difficult to import those chemicals. So what we are often doing is that we give the MSDS data sheets to the client, and then they source locally. They will usually never find exactly that product, but they are using then local products which are comparable, but they are not as effective than the cleaners from here, which we are developed by us. So it's easier for them to purchase them there. We accept it, we are okay for that, but usually they have to cover with a slightly or with sometimes also drastically reduced cleaning efficiency. That means maybe they need to use or they need to do a chemical cleaning for a UF membrane instead of every 6 or 7 weeks, maybe they need to do it every 4 weeks because the efficiency of the cleaner is reduced. But to answer it clearly, yes, it's possible to use local chemicals.
All right. We still go ahead and have several questions, but this is the question from Mr. Karim. Why does WEHRLE use the injection of the air instead of pure oxygen into its treatment plant? Mbbr, for example, plant needs normally oxygen injection, pure oxygen injection, sorry, and it becomes the key parameter of the design and plant performance. But in here in Mbr, you explained that we just inject the air instead of pure oxygen.
Yes, clearly we never in our plants inject pure oxygen since it's much more expensive. It will increase the OPEX drastically if you need to have a own machine for producing pure oxygen. The reason is with our ejector system, our aeration ejector system, we can use just normal air. For sure, the oxygen content in normal air is much lower than in pure oxygen, but through our ejector system and through the really high water table, we have a really good alpha factor. Alpha factor means how good can the oxygen go into the microorganism. This high alpha factor helps that we can handle and that we can run the plant with normal air and not with pure oxygen. If you have a really low alpha factor, out of your 20% oxygen in the normal air, you get not sufficient oxygen into the microorganism. But if you have a really high alpha factor, that 20% in the air are enough out of that 20% which go to the microorganism. Therefore, we do not need pure oxygen. We are running the plant really successfully with normal air. and which helps us, that fact, to have a much lower OPEX compared to pure oxygen.
All right, thank you, Mr. Simon, for your explanation. I believe that was the last question that we can accommodate in this webinar. Unfortunately, due to the limited time, I believe I need to end this webinar very soon. Thank you again, Mr. Simon and Mr. Kevin, for your presentation. And also for the attendees, as I have mentioned before, there will be a gift for you who actively address your questions to the speakers. Therefore, one person who is lucky to receive this gift is Mrs. Hajra. Congratulations. We will contact you separately for the detailed information. And as well as I mentioned before, in the beginning, after this webinar, we will send to each of you the slide presentation, and also will upload the recorded video in our Vela social media account. You can find our social media account, our YouTube channel, Xing channel, or LinkedIn. You will receive the link of the video after the end of this webinar to your registered email. You are very welcome to having further communications with our speakers. As you can see on the screen, there are Mr. Simon Goetz from company Vela, and then Mr. Kevin Negoro Kasih from BFS. You can find their website easily on Google, and you're very welcome to communicate further with them. Thank you again. And from my side, have a nice day, and we will see us again in the next webinar probably. Thank you. Good day, ladies and gentlemen.
Thank you very
See you.
much.
Bye
Thank
bye.
you. Bye bye.
Thank you. Bye bye.
Bye bye.